6, analyzing lines of best fit. So we already talked about how to find a line of best fit. Now we're going to look at different ways to analyze it. So a couple definitions. We're going to talk about linear regression. This is a method used on your calculator to find the line of best fit. Then we're also going to talk about line of best fit. That is the trend line that most closely matches your data. So we talked about drawing that line of best fit that goes through as many points as we possibly can. Then we're also going to talk about residual. What is a residual? That is the distance a point is vertically, so up and down, from the line of best fit. If the point is above the line, the residual will be positive. If the point is below the line, the residual will be negative. So looking at this graph they have next to this definition, I can see that I have my line of best fit, and if I wanted to know the residual of this point right here, it would be positive 1, 2, 3, because it is 3 spaces above my line. If I wanted to know the residual of this point right here, it would be negative 1, 2, because I am 2 spaces below the line. If a point is on the line, your residual would be 0 of that point. So let's practice that. Let's look at another graph and see if we can figure out the residual of a couple points. So what is the residual of 3, 2? So 3, 2 is this point right here. And I can see that it is 1 space below my line. So my residual would be negative 1 because it was below my line and it was 1 space vertically from my line of best fit. Okay, then I want to look at the point 2, 5. 2, 5 is this point right here. And I can see that that is 1 space above my line. So since it's 1 above, my residual is going to be positive 1. Okay? Then let's look at 5, 1. 5, 1 is this point right here. And that is on my line. So since it's on my line, the residual is 0 because it's no distance from my line. It's on the line. All right, now let's get out our calculators and we're going to find our line of best fit using our calculator. So I have some steps for you. So open up your calculator and we're going to use this table that they have given us on our packet, on our notes. Okay, so we need to type in this table into our calculator. So if you look at our steps, the very first button we are going to press is the stat button, which is right underneath delete. So if we hit stat, then it comes up with this screen and it tells us to press edit. So I'm already on edit, so I'm going to hit enter. Then I want to enter my data. The X's are going to go into this L1 column, and my Y's are going to go into this L2 column. So I'm going to type in that data. 1, 2, 3. Oh, I don't have 3. 1, 2, 5, 8, 9, 17 are going to go into my L1 because those are all my X's. Then into my L2 column, I'm going to press 30, 55, 75, 120, 145, and 250. Make sure that your data ends at the same point because we have the same number of X's and same number of Y's. So now that we've entered our data, let's look at our next step. We need to press that stat button again. is highlighted. Then I want to press the number 4 where it says linear regression. We are trying to find a line of best fit. So I want the one that says line. So if I arrow down to 4 and press enter. Now it's going to double check that we use list 1 and list 2. We should never really have to change these in our calculator. So if I keep hitting enter, I have my equation. So we need to substitute, they gave me 13.5, I'm going to round up to 5.6, so 13.56, I'm going to substitute into A, so that would be y equals 13.56x, and then what was that B they gave us? 17.5, I'm going to round up because it was an 8 after that 8. So 5.9, so that would give me a B of positive 17.59. And that gave me my equation. Okay, so now there is a step, if you don't have it and I don't have it on my calculator, we're going to have to turn R on. All right, so in order to turn that R on, we're going to hit second, and then our 0 button where it says catalog right above it. Okay, once I'm into this entire catalog, I'm going to hit my X -1 button. If you see it, it's right underneath math. Because I want to go to my section where I have all of my D options in my catalog. So once I get to that and I press that X to the power of -1 button, I'm going to arrow down until I see diagnostic on. When I see that, I'm going to press enter twice. And it's going to tell me it's done, so it did it correctly. Once I have that on, I shouldn't have to change it in my calculator again, but you can always come back to this if it does not always stay on. So now I'm going to go back to what I did. So I went to stat, and I calculated my linear regression. So now that I have that diagnostic on, it's going to tell me an R squared and an R. These are super important. So if we have, in this one, we're going to pay attention to just what the R is. So I'm going to write that down. It tells me that my R is 0.9955. So I'm going to write that down where it says what is the R value. So 0.9955. So if I look at these graphs below on my packet, it tells me my different types of R. If I have an R that is closer to 0, I have a weak correlation. So if you look at this first graph, this is my line of best fit, and my data is kind of all over the place. So that weak correlation tells you that your line of best fit is not very close to your data. The closer your R is to 1, so like a 0.9, that tells you that your line of best fit is very close to your data. So like these last two examples, we have an R of 0.984. So this shows that my line of best fit is very close to my data. Same thing on this one, we had an R of negative 0.995. It's very close to my data. The only difference is this one's positive and this one's negative. That just tells me if my slope is positive, my R will be positive. If my slope is negative, my R will be negative. So, what's our cutoff point? If your R positive or negative does not matter. So let's look back at that example that we were doing and figure out, was this a weak or a strong correlation? We had an R of positive 0.9951. Since that is above 0.8, I would say that we have a strong, and since it was positive, I'm also going to say positive correlation. So if this would have been a negative 0.9955, I would say a strong negative.